The primary difference between us and what you see in Hadoop, the most glaring difference is we're not predicated on MapReduce. So when you decide to go with a MapReduce architecture, after you implement it, the real work has begun. I mean, the serious, hard, laborious work, because now you have to take these algorithms that model big data and convert them into MapReduce. And that's not always an easy proposition. Sometimes it can be very challenging to do. So in our environment, you're taking a big data problem and you're modeling it as a big data problem. And that lends itself to solving these problems very quickly with far less code. And then you also don't have to worry about all of these other issues that crop up around managing chains of MapReduce jobs to get the answer that you want.
So would there be would I be setting up my hardware differently as well in the two solutions?
Hardware, now that's a good question. No, you don't need to. The idea here is that if you're using commodity hardware for, say, a Hadoop cluster, you should be able to use that same hardware for an environment such as ours. Commodity hardware with nothing specialized within the hardware, no secret sauce there. Just following best practices in terms of setting up big data clusters.
I'm just curious, I don't know if this fits in the thing, but do people run this in a virtualized environment at all, or would that be counterproductive, do you think?
Oh, they do. There are a lot of entities that reach out to us and they say things like, we need 2 or 3 months to approve any new software that gets onto any of our systems. Can you help us run it in Amazon? And so Amazon is a virtualized environment, and it's one we support. In fact, we just recently announced some additional support around Amazon. And in the future, you'll see closer integration with cloud environments like Amazon.
Okay. So can you tell me more about the speed of development as an advantage for HPCC?
Sure. That's one that LexisNexis lives and breathes every day. It allows us to get solutions out the door very quickly. And there's a couple of ways in which you can think about that. The first is that the platform is a single platform with not a lot of moving parts because of the decisions we made in its architecture, specifically to build big data solutions. So that when an ECL engineer sits down into his IDE, he has full control over that data from ingestion, and we're not doing any pre-processing. We have full control from ingestion all the way to data delivery. And instead of having, when we need to build a new solution, instead of having 5, 10, 15 different people in a room to come together and agree on all of these moving parts in a complex architecture, often you have that one guy, that ECL engineer, and he can get that solution out the door very quickly because of that lack of friction within the organization. But the second is the language itself. The ECL language is extremely productive. You're not writing a whole lot of code to get the job done on a parallelized cluster. You are really just doing 3 things, usually. You're telling the system what it is in terms of the data that you have. You're telling the system how you want the data transformed, and then you're telling the system how you want to deliver that data. And even though it seems very simple to talk about it in those terms, it can be very powerful in its simplicity.
You have a relatively mature technology, 10 years old, something like that. Why go open source?
Open source. There's a number of different reasons to go open source, but the primary reason, the most important one, is community. To have a community of folks using our technology is very powerful, and to build that community. And if you look at a number of technologies out there in the past, you can see that there were competing technologies that were far superior, but they didn't always win out, or they didn't always remain relevant, even if it wasn't a direct competition. A great example might be OS2 Warp versus Windows 3 or 3.1, or ISA versus ISA, or VHS versus Betamax. What's really important there is intelligent people continuing to use the system for new problems, to continue to contribute to the community, and to build that growing group of individuals who think about big data problems every day and solve big data challenges. And so that's really what we're getting from open sourcing.
So given that, what's on the horizon for HPCC?
Oh, there's a couple of things. One of them I've already alluded to, closer integration to cloud environments such as Amazon. Another one that we hear quite a bit is machine learning, and we're making some significant developments along those lines, and we'll be making some announcements in the near future about machine learning. Internships. Students are thinking about internships, especially the folks here at Stanford University, where we're sitting right now, and we do have internships available as well. And I think in terms of on the horizon, that's probably as much as I should be talking about right now.
So if I have big data problems, how can HPC help me? Do I have to switch religions?
No, it's really simple. If you're here at Stanford University today, you just stop by and pick up a USB with all of our software, our source code, precompiled binaries, documentation, presentations, and you can begin going through the examples. If you're a business thinking about these things, you can reach out to us and talk about specific big data challenges. We have data scientists standing by who think about these big data challenges every day, and as you mentioned, have more than 10 years of experience solving those big data challenges in an enterprise environment. And you can use the open source software, and when you're interested in indemnity and additional support and additional training and so forth, that's when you can talk to us about the dual license and the enterprise opportunities.
So we're here at the HPC Advisory Council workshop. A lot of hardcore HPC folks. What are you hearing from them about what you presented today?
Probably, I hear quite a bit about Amazon. There's always questions about Amazon. I think that's generally around adoption. Amazon makes it really easy to adopt new technologies very quickly without interrupting your existing environment. We're hearing quite a bit about machine learning. We mentioned it in the presentation, and already had a couple of professors and a woman from a national lab come up and ask us questions about machine learning. I would say, too, we hear quite a bit about the interests of the students, what they're interested in terms of internships and those sorts of things, where the internships available. And I'd say that that's probably where most of the discussions are lying right now.
So if you were a bright young student back in those days, would this be a great area to get into, do you think?
Oh, definitely. And I'll tell you why. When you look at a lot of the new business models that are coming out nowadays, it's all about data. And it's those individuals who can process big data who are going to enable those new business models. I think that's where a lot of the new jobs, new opportunities, and quite frankly, where a lot of the money is going to be in the future.